Assalamu alaikum. We know when an object is thrown with some initial velocity in air and allowed to move only under the action of gravity, then such object is called as projectile, and the motion is referred as projectile motion. Now, projectile motion is classified into two, as horizontal projection and vertical projection. In this video, we discuss about projectile in horizontal projection. For that, I consider an object which is thrown from a point at a height h from the ground. Here, the height of this point is h. From this point, an object is thrown with some initial velocity. Okay, when it is done so, it starts moving in this direction. It traces this path before hitting the ground. Let me extend this. This is the point where it hits the ground. Clear? And as I have told you earlier, here the object is provided with some initial velocity. Let us take it as u. Okay, and this initial velocity has got only component along the horizontal direction. It has got no component along the vertical direction. So its initial velocity, it has got horizontal and vertical component, means here uy is taken as 0 initially. Okay, so it has got only horizontal component. Clear? So what does it mean? Here I am using the term horizontal and vertical. See, if the object is thrown in this manner from this point, it moves along the x-axis. Here, for my convenience, I take this as the x-axis, and this axis is taken as y. Currently speaking, this is the minus y-axis, but here it is considered as positive y-axis for our convenience. Now, the motion along x-axis is a horizontal motion, and the motion along y-axis is considered as vertical motion. I write it here. So vertical motion. This is the horizontal motion or horizontal direction. When object moves along this direction, that means it is moving along the horizontal direction. Understand? So here, how could I say that it has got both the horizontal and vertical motion? There is a reason for that. See, when the object is thrown from some initial velocity, it moves forward. Okay, it is obvious from the point where it hits the ground. It is away from this point. Clear? That means the object has moved along the x-axis, along the horizontal direction. Second thing, the object after motion has shifted to a point which is located on the ground at the bottom. So this clearly shows that the object has moved in the downward direction as well. So the object has got two components, one along the horizontal direction, another along the vertical direction. I hope I have understood. Let's go ahead. So first I'll discuss the motion of the object or the motion of the projectile. When I say object here, object is nothing but projectile. Remember this. I have made a separate video on the horizontal projection. There I have explained what is a projectile. Anyhow, for better understanding, I tell you, any object which is thrown with some initial velocity, with some velocity, is referred as projectile. It may be anything. It may be anything. If you throw a ball from the window of a bus, car, or a train, or even from your house window, that object or that ball that you throw is referred as projectile. Next, if you throw a stone, that stone can be referred as a projectile. A shot put javelin thrown by an athlete. Here, a shot put and javelin is nothing but projectile. A bullet fired from a gun is an example of a projectile. So here, the motion of these projectile is referred as projectile motion, and this process of projecting or throwing the object is called as projection. Remember these things. Now let's go ahead. And here, before going ahead, let me tell you one more thing. What is the horizontal projection? Here, when we throw an object from certain height in such a way that the velocity is given in the horizontal direction, then we call such a projection as horizontal projection. Understand? Let's go ahead. As I told you, I am going to discuss the motion of this projectile in a horizontal direction. It's the motion in horizontal direction. Motion in horizontal direction. Let's see, what is this? To discuss the motion in horizontal direction, I start with whenever we talk about the motion of a projectile, we use the three equations of motion. What are the equations of motion, which are otherwise known as kinematic equations? Equation of motion. First equation of motion. Now I have made a separate video on this. The first equation of motion is v is equal to u plus at. It relates the velocity and time. The second equation of motion is s is equal to ut plus half at square. It relates the position of the object with the time at any given time, or we can simply say it relates a displacement with the time. Third equation of motion now gives the velocity, or we can say give the position of an object at a particular time. V is equal to u square plus 2as. These are equations of motion. I am going to use them here to discuss our problem. Okay. Now, motion in horizontal direction. Here, we'll consider only the motion of a projectile along a horizontal direction. For that, I take a second equation of motion. Second equation of motion. Second equation of motion. So what is that? Is present here. S equals to ut plus half at square. Here s is the displacement, u is initial velocity, t is the time, and a is acceleration. Okay. Now, in case of horizontal I'm sorry, the motion in horizontal direction, the object have initial velocity u equal to ux. Okay, fine. And here this velocity along the horizontal direction is uniform velocity. It means that its value remains same throughout the motion of the object. It doesn't change. Here it's a constant or the uniform velocity. So acceleration is 0. Why it is 0? What is acceleration? Now, to write this one as 0, we must know what is the acceleration. Acceleration is rate of change of velocity. When the velocity does not change, then the object will not accelerate. So acceleration will be 0. Clear? See here, acceleration is the rate of change of velocity, du by dt. Here u is a constant. It is a constant. When we differentiate a constant, what do we obtain is nothing but 0. No, that is why acceleration is 0 here. Clear? Now we got these two things. Now that I am going to substitute here in the above equation. This is equation number 1. Now, substituting u and a value. And now equation number 1. So what I get in place? So a, get this. And one more thing, I will also write the value of s. Now here s can be taken as x. Okay, this is the distance traveled by the object along a horizontal direction. Okay, s x gives the distance traveled by the object in a horizontal direction. So in the place of s I have taken x, in the place of u I write ux, and t is kept as such. Then half, in the place of a write 0 and t square. So what I'll get, the next step I get this x is equal to when we multiply anything with a 0, what do we obtain is nothing but 0. So x is obtained as the multiple of ux with a t. Okay, this I take as equation number 2. Fine. So here we got the displacement or a distance along horizontal direction. Okay, and from this I am going to get the value of a t. T is the time taken to travel this much a distance by the object. Clear? So here I'm going to take I'm going to get the value of t. How I will do that? With that, I keep a t here as such. Ux is taken to the another side. Here it is multiplying with t. When it is taken to the another side, it will divide. Okay, x upon ux. Understand? This is the time taken. Okay, I take this is equation number 3. This is how we get the value of t. Now we'll discuss the motion of the projectile in a downward direction, or motion of the projectile in a vertical direction. Okay, motion in a downward, that is the vertical direction. Understand? Let's do it. Here again, to discuss the motion of the projectile in vertical direction, I take a second equation of motion. That is nothing but this, s equals to ut plus half a ut square. Second equation of motion. What is this? This equals ut plus half ut square. Understand? Now I'll go ahead. Now I'm going to make certain changes to this according to the case. Here, when the object is thrown initially, we only provide a initial velocity to it. That initial velocity possesses only horizontal component, doesn't have vertical component. So here u, which is nothing but initial velocity, is taken as uy, and it is nothing but a 0. Clear? And the object, you can see, moves in the downward direction. Here the vertical velocity is actually changes uniformly with time, and it is due to the acceleration, or it is due to gravity. Clear? That's why here acceleration is actually due to gravity. So a is replaced with the g. I'm sorry. Then here distance, displacement in a given direction is taken as a y. Okay, here s is replaced with the x. So here I'm going to replace s with the y. Now let's do it. Now I'm going to substitute the value of substituting the value of u, a and s in the equation number 1. See what I get if I do so? The above equation. If I substitute all these things here, this is nothing but equation number 1, isn't it? Let me write it here. That I have already mentioned this side. So here, the place of s, I write 1. I write 1. Then in the place of u, x, I'm sorry, the place of u, I write uy. There is nothing but a 0. No? Okay. Plus half, the place of a, I write g square. Then the next step, I'm going to substitute the value of uy. So y equals to 0 multiplied with t plus half a g t square. So what do I get now? I get this equation, y equals to half g t square. Now I take this as equation number 4. Now we know the value of t is given in equation number 3. Then I will substitute here in 4. Substituting equation number 3 in 4. What I will get if you do so? Let's find out. Here, y is equal to half, the place of t, I write its value. There is nothing but x upon ux. X upon ux. Whole square. I square it. Okay. Now look at this carefully. I'm going to make certain changes to this equation. See, what are those changes that I make? Now, if you look at the left hand side of this equation, you must find it has got the half, which is a numerical constant. Here g, acceleration due to gravity. Again, it is a constant for a particular place on the surface of Earth. Then here x, what is this x? X is the distance traveled by the object along horizontal direction, and ux is the velocity of the object in the horizontal direction. Okay, it is a constant thing here. Now what I do, these three constants, half g and ux. Why ux is constant? Because it is a uniform velocity. No, here ux is a constant. In a similar way, this is also a constant, isn't it? So this entire term, which I consider as a constant, is taken out and written aside, okay, in this manner. So I write y equals to half g, then ux. Now it is squared before taking out. Ux square. Per term is multiplied with the x square. Okay, so this is a constant. This I have mentioned earlier. Now, next step. See what I get? I get this. Y equals to a constant multiplied with the x square. Understand? Fine. Now, we know very well, when we combine constant with equal to sign, we get a proportionality. Okay. The same thing I will get here. On combining these two, get a proportionality. And I'll do one thing. Instead of before that, I will give some name to this constant. I name this constant as k. I name this constant as a k. So write k here, x square. Now I get an equation. This equation is nothing but equation of parabola. Okay. So if I compare these two equations, what I get this. I get the value of k to be equal to half g upon 2x square. This is the constant term present in this equation. Okay. Now I am going to combine this constant with the equal to sign. I will get y is directly proportional to x square. Anyhow, now before that, I will name this equation as equation number 5. This equation number 5 clearly shows that the path followed by the object to reach the ground is nothing but parabola. What is this? I take one point here, I name it as B. So this point is named as O and this is named as A. Here O is the point from where the object is thrown and A is the point where it hits the ground, and P is taken a point somewhere in the trajectory, in the path. Okay, here OP is a parabolic path from the diagram. So how do we confirm that? It is confirmed from equation number 5. This is the here equation number 5. 5 is the equation of a parabola. So from this it is clear that the path followed by a projectile when it is thrown is nothing but parabola. Now we will get the expression for time of flight for the projectile in a horizontal projection. Now before going ahead, let me tell you what is the time of flight. The time of flight is usually represented by letter T, capital T. Time of flight. Thus, in some cases, it is also represented as TF. Okay. Anyhow, what is this? Time of flight is nothing but the time taken by the projectile to reach the ground from the point of a projection. Here in our case, the object is the projectile is thrown from point O, and the point A is present on the ground where it hits the ground. Okay, So here the total time taken by the object to reach A from O is referred as time of flight, represent letter capital T. Okay. Now to get the expression for time of flight, again I use the second equation of motion. Second equation of motion, which is nothing but S equals to ut plus half at square. S equals to ut plus half at square. Understand? Now I'll go ahead. Now I'm going to make certain changes to this according to our case. Here the object is found to be traveling in the vertical direction to reach A, isn't it? So S is taken as Sy and U is taken as Uy. Here U stands for initial velocity. As I told you earlier, initially the object do not have any component along the vertical direction. So Uy is 0 in such case. And here, as the object moves downward, it is influenced by gravitational force. So here the velocity keep increasing as it moves downward. So whenever velocity changes with time, we call this as acceleration. Okay, and here this acceleration, that is A, is due to gravity. So A is replaced with a G. Okay, now I'm going to write all those things here in the above equation. So this equation will get a new form, that is Sy equals to Uy multiplied with the T. Here one more thing I forgot to mention. Here T is the time taken by the object to reach a particular point. Whereas here the point or the destination of the object is A. Okay, so we have to consider the total time. So the total time taken is the represent letter capital T. So small t has to be replaced with the capital T here. Let's do it. So in the place of T, I'll write a capital T, which represents the time of flight, and half G T square. And here Uy is nothing but 0. Okay, so this term becomes 0 plus half gt square. So what do we obtain is nothing but this. Sy equals to half gt square. Gt square. Now here I'll do one more modification to this. What is that? In the place of Sy, I'm going to write a y. Okay, if so, then I'll get this equation. Y is equal to half gt square. Now what is my aim? My aim is to get the value of a t. Okay, which is present here. So I'll keep only this term on one side, and the remaining thing is taken to the other side. If I do so, what I'll get? I get this t square kept as such, and remaining term, that is half g, is taken to the other side. So here 2 is present in the denominator. So when it is taken to the other side, it will multiply. It will become 2y, and g, which is the numerator, while taking to the other side, will go to denominator. This is the value of t square. Now from this, I am going to get the value of t on taking square root. I am taking square root. I get this. I get t equals to root of 2y upon g. Okay, and here one more thing. Here y which represents the vertical vertical direction. Now actually this can be calculated by measuring the height of the tower on which from which the object is thrown. Okay, and here so on that way the height is the given letter h. So in the place of y we can write h as well. Okay, so that I would have done earlier here itself. Anyhow, no problem. So I'm going to replace y with here y is equal to h. So what I'll get? I get this. I get the t value to be equal to root of 2h upon g. This is the final expression which gives us time of flight. Okay. Now this is taken as equation number 6. Now before going ahead, let me provide us some information about this equation. Here I told you t stands for time of flight. It is the total time taken by the object to reach the ground from the point of projection. Clear? And if you look at this, you will find that here we have got only two terms on the left hand side of this equation. One is h, another is g. Here g is the acceleration due to gravity, which is a constant for a particular point, for a particular place, and 2 is a numerical constant. So this clearly shows that t depends only on the height of the building and doesn't depend on other parameters such as the initial velocity with which it is thrown. Let me write this one here. Here in this equation, t equals to, this can be written as root of 2 upon g multiplied with the root of h. Okay, and here this term is a constant. So we can write this equation as t equals to constant multiplied with the root of h. Now when you combine equal to sign with constant, what you obtain is nothing but this. This proportionality. T is directly proportional to root of h. I box this. This clearly shows that time of flight t depends on height of the tower. Okay, and t does not depend on initial velocity with which the object is thrown. Okay, now this will understand easily with the help of a simple diagram. Now suppose there is an object present here. It is dropped from here. Okay, from certain height. Let this height be h. The height is h. From height h, an object is dropped. Just simply we drop it. And a second, from the same height, an object is projected with some initial velocity. When we project that object, it follows the parabolic path to hit the ground. Okay. So here in the second case, some initial velocity, maybe u, is given to the object along horizontal direction. But it is observed that the time taken by this object to reach the ground is a t, means the time taken by this object which is thrown with some initial velocity is also t. This shows that time taken by the object to reach the ground does not depend on initial velocity, but it depends on height of the tower from where it is thrown. Okay. Now we'll get the expression for range, which is otherwise referred as horizontal range and represent the letter capital R. Now, I have mentioned this one here in the diagram. Here capital R represents the range, and it is nothing but the horizontal distance covered by the object along this horizontal line. Okay. Now let me get the expression. To get the expression of R, I start with the equation number 1. I take a second equation of motion. That is S equals to ut plus half at square. Now here I am going to make certain changes to this. Here I told you we measure range along the horizontal direction. So S, which represents the displacement, is taken as capital R, range as the range. Then U is taken as Ux. So we consider only the motion of the object along the horizontal direction. So the initial velocity is taken as Ux. Now we know Ux is constant, so it remains same throughout the motion of the object. Hence the acceleration is 0 in this case, and t is nothing but time of flight, which can be obtained from equation number 6. Okay, right here it is a value of t, it is root of 2h upon g. I am going to mention all these things in equation number 1. So in the place of S I will write R, in the place of U I write U, X, in the place of T I write 2h upon g, and in the place of A I write 0, then in the place of t I write the square of this, which is nothing but 2h upon g. Anyhow, when we multiply this, it becomes 0, and what we obtained is nothing but this. R equals to Ux multiplied with 2h upon g. Now what do we understand from this expression? I take it as equation number 7 and I box it for better visibility. Now here, if you look at this equation, you find it consists of 3 parameters on the right side. One is Ux, other one is 2h, and second one is, third one is g. This subscript is written at the bottom like this. Right? Here, this equation is R is written as root of 2h multiplied with Ux upon root g. Here it is a constant, so we get a new expression. In the place of this, I write constant, and the remaining thing is mentioned here as such. Now when I combine constant with equal to sign, I get a proportionality. So R is directly proportional to Ux upon root g. Now this clearly shows that R depends on initial velocity and acceleration due to gravity. So I can say R is directly proportional to initial velocity and R is inversely proportional to rate of acceleration due to gravity. Understood? The next we'll get the expression of velocity of the projectile at a given time. To get the resultant velocity, I take a point P on this trajectory. Here at point P, the velocity has got two components, one along the horizontal direction represented by letter Vx and another along vertical direction represented by letter Vy. The resultant of these two is found to be acting along the tangent. No? So I take it as V. This line V makes an angle beta with the Vx. Clear? Now let me draw this one here separately. This Vx, this line represents Vy. The resultant of these two acts along this line represented by letter V, which is the resultant of Vx and Vy. It makes an angle beta with the Vx. Understand? Now, to find the V, I must know what is Vx and Vy. Okay. So here, to get the value of V, I take a equation, first equation of motion. First equation of motion. For remaining things, we used second equation of motion. For this, we use first equation of motion, which is nothing but V equals to U plus AT. Okay. Now here, along horizontal direction, that is along the x-axis, along x-axis, V is taken as Vx and U is found to be Ux. That is the initial velocity. And here we know the initial velocity along the horizontal direction remains the same throughout the motion of the object. Okay, so acceleration is 0 here. And next t is taken as the time of flight or time at that particular point, whatever. Anyhow, that we are going to get 0 when we multiply the value of A with a t. So I need to mention that one here. So by substituting all these things here in this equation, I get in the place of V, I write Vx, and in the place of U, I write Ux, and here 0 multiplied with a t. Okay, so this shows that Vx is equal to Ux. This I take as equation number 8. Okay, so now I will find out the velocity component along y-axis. Along vertical direction. Along y-axis. What is that? Here again I use a first equation of motion, V is equal to U plus AT. Here the velocity component along y-axis is nothing but Vy and the vertical component of initial velocity is Uy, which is 0. Because there is no vertical component along the vertical direction at the beginning. Okay. Next step. Here A is taken as g. Acceleration is due to gravity. And what is small t? T is the time. Okay, so I'm going to write the value of all these things in this equation. So I get after substituting this given value, this equation becomes Vy equals to, here in the place of u, I have to write a 0. That's G T is what I get. Fine. So this shows that Vy equals to GT. This is equation number 9. I box it for better visibility. Then I'll move ahead. Now I'm going to split V into its components. V is split as Vx and Vy. This is the component of V along x-axis. This is the component of V along y-axis. So V can be written as Vx I cap plus Vy j cap according to component method. Now here, that we have discussed earlier, I take this as equation number 10. In equation number 10, I am going to substitute the value of 8 Vx and Vy. Okay, as we have a direction this side, vector symbol can be mentioned here. So V is, what is the value of Vx? It is Vx I cap plus the place of Vy, right? GT j cap. Fine. This is the expression which gives us velocity at any given time. Okay, or simply this is the resultant velocity. Now its magnitude of V vector. No, that is nothing but V can be obtained by taking square root of addition of Vx square and Vy square. Now this final expression provides us the magnitude of the velocity vector at point P. Clear? Or magnitude of resultant velocity. Now I'll get the expression for the speed of the projectile where it hits the point A on the ground. Okay. Speed of the projectile when it hits the ground. When it hits the ground. Here, whatever we have obtained in the previous section, that is the equation number 8, 9 and 11 is used here in this section to get the speed of the projectile when it hits the ground. Okay, and only one change we make here is nothing but in the place of t, small t, I use capital T, which represents the time of flight, because when it reaches point A, it means it has covered the total path, and here it has come to rest. Okay, this is what so Vx is taken as Ux. Instead I will I'll use equation number 8 from 8 Vx is taken as Ux, then from equation number 9 Vy is taken as a Gt. Fine. Now this I am going to substitute here, equation number 10. Now before that, I am going to replace small t with the replacing small t with the capital T. What I get? Get this new equation for Vy, which is G multiplied with the capital T. I take this as equation number 12. Okay. So I am going to use the value of Vx and Vy in equation number 11 using Vx and Vy values in 11, equation number 11. What I will get? I get this V equals to root of, what is the value of Vx? It is Vx plus the Vy square, Vy square, right? G square T square. Okay. And if you want, you can mention the value of T here. What is the value of T? The value of T is this. T is time of flight, which is about root of 2h upon G. Okay. If you use this one here, what do you get? You get this V value found to be equal to root of Ux plus G square. The square of T square is nothing but this 2h upon G. Clear? So here this and this get cancelled, and in the next step we get its value to be equal to this much, root of Ux plus 2gh. This final expression gives us the speed of the projectile when it hits the ground. Here, as we know very well, Ux represents the initial velocity with which the object is thrown. Now, which remains the same throughout the motion of the object. Okay, so this can be written as U. So instead of writing Ux, this can be here. This can be replaced with the U. So I remove X from all the three equations. Okay. Now, for better visibility, I am going to write this final expression here, as I don't have space down. So V equals to root of U square plus 2gh. Then I'm going to box it for better visibility. Now I should have written this one here, as there is no space, so that's why the final expression is taken to this part of the board. Okay. So using this equation, one can easily find out the speed of the projectile when it hits the ground. Okay. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.